Solve problems on control charts for attributes by using first control chart for the fraction defective P chart, second control chart for number of defectives NP chart, third control chart for number of defects C chart.
Let us understand some important formulae related to P chart. We will consider sample size n and number of samples is equal to k. To plot the P chart on horizontal line, we have to plot the sample number, that is sample number 1, 2, 3 up to k, and on vertical line we have to plot the fraction defective. Now how to calculate fraction defective? So its a notation is P. So fraction defective in sample P is equal to number of defectives in each sample, that is D, divided by sample size n. Now in short we will say that for each sample we have to take the defective. So for sample number 1 we will consider defective is D1. So I will take here D1 divided by n. Now for sample number 2, defective is D2. So I will take here D2 divided by n. And for the k number of sample, that is for kth sample, dk divided by n. So in this way we have to calculate the value of P and we have to plot on this vertical line. Now we will move to the next, proportion of defectives by entire process. So here this is the fraction defective for one sample or for second sample. So each sample this P is calculated. But for the entire process, that is for the all number of samples, how to calculate the proportion of defectives? So proportion of defectives notation is P bar and its a formula is D1 plus D2 plus dk divided by n into k. Now we already know what is D1, that is the number of defectives in sample number 1, D2 number of defectives in sample number 2 and so on, and divided by n, that is the sample size, and k number of samples. So by using this formula we can calculate P bar. Now suppose in question there are different sample size given, then how to take the value for this n. So for the different sample size, that is for the first sample, sample size n is different, for second sample, sample size is different, then we have to take the average value n bar, and we have to use here instead of n we have to use n bar for the different sample size. Now we will move next. So next is standard deviation. So for P chart standard deviation we have to write sigma to the base P, and its a formula is P bar in bracket 1 minus P bar by n, and full formula is under square root. So we have to take this formula or we have to calculate sigma P by using this. So which parameters are required to calculate standard deviation, that is P bar is required and n is also required. Now in this formula also for different sample size, instead of n we have to consider average sample size, that is n bar. Now we will move how to calculate the control limits. So here first we have to calculate centered line. So for the centered line we have to take the value of P bar. Then upper control limit. So upper control limit is equal to P bar plus Z sigma P. So sigma P we have to use this formula. Now what is the value of Z? So value of Z depends on the probability of confidence or control limit. Now suppose in question there is some error is given, that is the error in percentage is given. Now we will say error in percentage is given 2%. So there is probability of this error. Then what is the probability of confidence? So 2% error, that means there is probability of confidence 100 minus 2, that is 98% is the probability of confidence. So we will say that probability of confidence is equal to 0.98. And by referring the chart given for the probability of confidence and Z, we have to find out the value of Z for the value 0.98. So that chart is provided in the examination. Now suppose the probability of confidence is not given and these control limits are also not given. So in this case we will consider probability of confidence 100%, and for the 100% probability of confidence we have to take the value of Z, that is equal to 3. So standard value of Z we have to refer here as a 3 when this probability of confidence and control limit is not given. Now in second case, when control limit is given in the form of sigma. So control limit is given, that is control limit 3 sigma is given. Then we have to use Z is equal to 3. Now control limit 2 sigma is given, then we have to use Z is equal to 2, and control limit 1 sigma is given, then we have to use Z is equal to 1. So in this way the value of Z is getting decided. Now for lower control limit we have to take the formula P bar minus Z sigma P. Now we will understand important formulae related to NP chart. So to plot this chart, on horizontal line we have to plot the sample number, and on vertical line we have to plot the number of defectives. To calculate number of defectives, that is NP bar, we have to use formula total number of defectives in all samples divided by number of samples inspected. Now how to find out the total number of defectives in all samples? So in sample number 1, number of defectives is D1, in sample number 2, number of defectives is equal to D2, and so on. So there are K number of samples. So in sample number K, number of defectives is Dk. So we will write here D1 plus D2 plus up to Dk, divided by number of samples inspected. So here number of samples is equal to K. So we have to take in denominator, that is K. So we have to calculate this NP bar by using this formula, and we have to plot the numbers on the vertical line. Now we will move to calculate standard deviation, and standard deviation for this NP chart is known as sigma NP. So how to calculate this? So we have to just multiply n for the formula of sigma p. So sigma p formula is under root of p bar 1 minus p bar by n, and we have to just multiply here with n. So if I take this n inside the square root, then here 1n inside the square root it will become n square, and 1n and 1n is getting cancelled, and when we simplify this, final formula for sigma np is under root of np bar into bracket 1 minus p bar. So by using this formula we can calculate the standard deviation sigma np. Now how to calculate control limits? So first is centered line. So for centered line we have to use np bar. So np bar is calculated by using this formula. Upper control limit np bar plus z sigma np. So sigma np we have to calculate by using this formula, and the value of z will depend on the probability of confidence and control limit that I have explained earlier. So here if probability of confidence and control limits both are not given, then we will consider probability of confidence is 100%, and we will take the value of z is equal to 3. So remember, if control limits and this probability of confidence or percentage error is not mentioned, then always take z is equal to 3. Then lower control limit is equal to np bar minus z into sigma np. Now we will move to C chart. So to plot the C chart, on horizontal line we will plot the sample number, and on vertical line we will plot the number of defects. And this number of defects, that is equal to C, and that is mentioned in the question. Then the number of samples, that is equal to K. Now we will calculate average number of defects, that is C bar. So how to calculate this C bar, and that is equal to total number of defects in all samples divided by number of samples inspected. So total number of defects in all samples, that is equal to D1 plus D2 plus up to Dk divided by number of samples. So number of sample is K, so divided by K. So by using this formula we can calculate the value of C bar. Now how to calculate the standard deviation for the C chart. So standard deviation for C chart, that is sigma to the base C, which is equal to under root of C bar. So we can calculate C bar by using this formula, and it is the value of sigma C, that is under root of C bar. Now we will find out the control limits. So centered line is equal to C bar, upper control limit is equal to C bar plus Z sigma C. So sigma C, that is, this is the formula. Then lower control limit is equal to C bar minus Z sigma C. Now suppose the probability of confidence or control limits are not mentioned in the question, then we have to consider the value of Z, that is equal to 3. Now this is the first part for the C chart. Now how to plot the chart for the number of defects per unit. So notation is U. So here we have to plot on vertical line number of defects per unit. Now in this case sample size n is mentioned in the question. So in previous case when we calculate C bar, in this case sample size is not given. But when the number of defects per unit, that means the sample size n is mentioned in the question. So in that case we have to calculate the number of defects per unit, that is C by n, and those value we have to plot on the vertical line. Then how to calculate the limits? So for these limits we have to calculate center line is equal to U bar. That means for each and every sample we have to calculate the value of C by n. So for the first sample value of C by n is calculated, for second sample value of C by n is calculated, and it depends on the number of samples. So how to calculate this U bar, that is value of C by n, we have to add value of C by n for each and every sample divided by total number of samples. So in this way this U bar is calculated, and then we will take the control limit, that is center line is equal to U bar, then upper control limit, that is equal to U bar plus Z under root of U bar by n, and lower control limit, that is equal to U bar minus Z under root of U bar by n.
Given question, each week a sample of 100 residents is questioned on their feelings towards the project. The results to date are shown below. Analyze this data using an appropriate control chart with 5% risk of type 1 error. Is the community sentiment stable? This question was asked Dayalbagh Education Institute, Agra, MBA, May 2010.
Let us understand given data. In this table, week is mentioned, so we will consider these numbers as a sample. Then the number opposed is also mentioned, so we will consider this as a defectives. Now we will draw here the P chart. So in this P chart we know that on horizontal line we have to plot the sample number. So here total number of samples, that is K, and which is equal to 8. And on vertical line we have to plot the fraction defective. Now in question sample size, that is n is equal to 100 mentioned. So now how to calculate the fraction defective? So this fraction defective we have to calculate for each sample. So for the first sample fraction defective is equal to 10 divided by 100. So which is equal to 0.1. Then next for this defective 8 divided by 100, so which is equal to 0.08. Then third it is 0.12. then 0.06, 0.04, 0.14, 0.08 and 0.1. So we have to calculate the fraction defective. Now if we make this total number of defectives for all 8 samples, so we have to add this number, and which is equal to 72. Now we will plot all this data, that is for sample number 1. So here is sample number 1, fraction defective 0.1. So it is in between 0.00 and 0.02. Now if we observe here, the minimum number is 0.04 and maximum number 0.14. So we have to plot the numbers on this vertical line starting from 0.00, and we will take here the equal distance. So you can take 1 centimeter, 2 centimeter as per the space available, and at equal distance we will plot the next number, that is 0.02, then next number 0.04, 0.06 and so on. So here we will plot for the sample number 1 fraction defective 0.1. So it is in between 0.00 and 0.02. So we will select here the middle point, and at this middle point I will make here 1 point. Then in the same way for sample number 2 it is 0.08. So here is 0.08. So for sample number 2 I will make here 1 point. Then third it is 0.12. So for this 3 we have to plot here as a 0.12. Then next fourth it is 0.06. So for the fourth sample number we will mark here 1 point, that is 0.06. Then it is 0.04, that is for the fifth sample number. Then for sixth it is 0.14. So we have to mark here 1 point. Then for seventh it is 0.08. So here is 0.08. So we will mark here 1 point. And then last for 8 it is 0.1. So again it is 0.1. So here is 0.1. So we have to mark here 1 point. So all the points that we have plotted. Now we have to decide whether all these points are within the control limits or not. So for that we will first find out the center line. So for this center line, what is the formula for CL? That is P bar. So how to calculate P bar? So formula is P bar is equal to D1 plus D2 up to D7 up to D8, because last number is 8, up to D8 divided by N into K. So here we have to take the defective. So defective for sample 1, D1 10, D2 8, D3 12, D4 6, D5 4, D6 14, D7 8 and D8 10. So if we add this, then we will get 72 divided by N into K, that is 100 into 8, that is equal to 800. So this P bar is equal to 0.09. So this is the control limit, that is control limit for the center line. So I will write here center line is equal to 0.09. Now we will draw here one line at this point 0.09. So this is the middle point in between the 0.08 and 0.1. So I will draw in the form of dash. So this is CL, which is equal to 0.09. Now we will move next. Now we will calculate upper control limit and lower control limit. So here 5% risk of type 1 error is mentioned. So there is 5% risk of type 1 error. That means probability of confidence is 100 minus 5, which is equal to 95%. So we will refer here one chart, that is for the probability of confidence and the value of Z. So when probability of confidence 95%, that is equal to 0.95, then the value of Z is mentioned 1.65. So we will consider here Z is equal to 1.65. So how to calculate upper control limit? That is equal to P bar plus Z under root of P bar 1 minus P bar by N. So this value of P bar is known. Z is 1.65, N is 100. So when we put all the value, then we will get 0.137. So this is the upper control limit. So if we observe 0.13 is in between this 0.12 and 0.14. So we will select here middle point and I will draw here one horizontal line in the form of dash. So this is the upper control limit. Then we will calculate lower control limit, that is P bar minus Z under root of P bar 1 minus P bar by N, and that is equal to 0.043. So here is 0.04. So here is 1 point 0.04, but again there is 0.043. So I will draw here one line, and that is for lower control limit. Now if we observe this chart, then the points for sample number 1, then the sample number 5, it is 0.04, and for the sample number 6, it is 0.014, are out of the control limits, that is are not within the range of this lower control limit and upper control limit. So we can say that this process is out of control.
Given question, 10 samples of different sizes were taken and number of defectives in each sample are noted below. Draw the control chart for the fraction defectives taking plus minus 3 sigma control limits. This question was asked. Dayalbagh Education Institute, Agra, MBA, May 2014.
Let us understand given data. This table is mentioned for the sample number 1 to 10, then sample size. So for each sample number there is different sample size and the number of defectives are also mentioned. So we can say that this is the question for the different sample size. We will solve this question by using P chart. Now for P chart, on vertical line we have to plot the fraction defective. So we will first calculate fraction defective for each and every sample number. So fraction defective for sample number 1, that is equal to number of defectives divided by sample size. So for this sample number 1, sample size is 100. So we can say that 7 divided by 100, which is equal to 0.07. Now for second sample number, sample size is 300. So fraction defective 12 divided by 300, which is equal to 0.04. Then 6 divided by 200, 0.03. 5 divided by 150, 0.033, and so on. So we have to calculate the fraction defective for all the sample number 10. Now we will plot here the points. So on the horizontal line we will plot the sample number from 1 to 10, and on vertical line we will plot the fraction defective. If we observe here the minimum number, that is 0.03, and maximum number, that is 0.09. So I will take here equal distance, so we can take here 1 centimeter or 2 centimeter as per the space available, and we will start from 0.00. Then after 1 centimeter 0.01, after 2 centimeter it is 0.02, then 0.03, 0.04 up to 0.1, that is we can say up to 0.10. Now we will plot the point. Now for the sample number 1 it is 0.07. So it is in between 0.06 and 8. So I will plot here one point, that is on vertical line we have to take this distance So this is for sample number 1. For 2 it is 0.04. So here is 0.04. So we have to plot here the second point. For 3 it is 0.03. So here is 0.03. Then next it is 0.033. So for the fourth sample number we have to take slightly greater than 0.03. Then it is 0.09. So here is 0.09. So it is for fifth sample number. So we will take here vertical distance, then horizontal distance. I will mark here one point. Then 6 it is 0.04. So for sixth again we have to take here 0.04. Then next for seventh it is 0.06. So here is 0.06. So for seventh we have to plot here one point. Then 8 it is 0.04. So again we will plot here 0.04. Then 0.03. So for 0.03 for ninth. So we will take here one point. And then 0.08. So here is 0.08. So for the sample number 10 it is 0.08. So we have to select here this horizontal distance. So these are the plottings of all the sample numbers. Now if we observe control limits are given, that is plus minus 3 sigma. So we will consider here the value of z, that is equal to 3. Now this is the case of the different sample size. So we will first calculate the average sample size. So it is the average sample size, that is the addition of all the sample size divided by number of samples, that is 10. So when we add all this number divided by 10, then n bar is equal to 200. So for the next calculation we have to use n bar instead of n. Now we will calculate p bar. So how to calculate p bar? That is the addition of all these defectives. So if we add all these defectives, that is this is the value of d1, that is 7, d2 12, d3 6, d4 5 and so on. Then here up to d10 this addition is 105 divided by n bar into k. So n bar is 200 and k, that is the sample number is 10. So 105 divided by 200 into 10. So answer is 0.0525. So if we observe the control limits, then for centered line this value we have to consider, that is equal to p bar, and that is equal to 0.0525. So here is 0.05. So here is 0.05. So I will take here the horizontal distance and I will draw here one line that is slightly above 0.5. So it is slightly above 0.5. We will draw this in the form of dash. This is CL. Now we will calculate upper control limit, which is equal to p bar plus z square root of p bar 1 minus p bar by n bar. So when we put all the values, so we have to take here z is equal to 3 and n bar, that is the average sample size, that is 200. Then we will get the answer 0.0998. So if we observe, that is approximately equal to 0.01. So I will take here, so 0. That is approximately equal to 0.1. So I will draw here one line passing from this 0.1, and that is upper control limit. Now we will move next, that is lower control limit, p bar minus z under root of p bar 1 minus p bar by n bar. So when we solve this, then we will get 0.0052. So here is 0.00 and here is 0.01. So in between these there is 0.0052. So I will take here one line from this middle point, and this is the lower control limit. Now if we observe this chart, then all the points lies within the upper control limit and lower control limit. So we can say that this process is under control.
Given question, 20 samples, each of size 10, were inspected. The number of defectives detected in each of them is given in the table. Construct number defective chart and establish quality standard for the future. This question was asked Dayalbagh Education Institute, Agra, December 2006.
Let us understand given data. Here sample number from 1 to 20 is mentioned with number of defectives. So the number of defectives 0, 1, 0, 3 and so on. Now we will solve this question by using NP chart. So for this NP chart, on horizontal line we have to plot the sample number, that is from 1 to 20. So we will take here equal distance and we will plot the numbers. And on vertical line we have to plot the number of defectives. So we will first plot the points as per the given table, because for the sample number 1, number of defectives 0. So here is the sample number 1 in between 0 and 2, and we will plot here the first point. Then for the sample number 2, number of defectives is 1. So for this 2, we will plot here the number of defective 1. Then for 3 it is 0. For 4 it is 3. So we will show here this is 3. Then for 5 it is 9. So for the sample number 5, here is 9. Then for 6 it is 2. Then for 7 it is 0. For 8 it is 7. So we will plot here the point 7. Then for 8 it is 7. Then for 9 it is 0. Then 10 it is 1. 11 it is 1. 12 it is 0. For 13 0. 14 3. Then 15 1. Then 16 it is 0. 17 0. 18 2. Then 19 and 20 it is 0. So in this way we have plotted all the numbers. Now we will calculate the control limits. So for the center line, control limit is NP bar. So how to calculate NP bar? So we have formula, that is D1 plus D2 up to D20 divided by K, that is the total number of samples. So if we observe, so I will write here as a K, because this is the formula. Now if we observe, we have to add all these defectives, and this total, that is equal to 30. So this 30 divided by K, so sample number is 20, so 30 divided by 20, that is equal to 1.5. So value of NP bar is 1.5. So we can say that the center line is also, we have to plot at 1.5. So if we observe in between this 1 and 2, we have to show here the center line. So this is the center line. Now we will move for the next. So next is upper control limit. So for upper control limit, formula is NP bar plus Z under root of NP bar 1 minus P bar. Now value of Z we have to consider 3 because no any probability of confidence or the control limits are mentioned. So standard value is 3. So value of NP bar is 1.5 plus 3 under root of again 1.5 in bracket 1 minus P bar. So how to calculate the value of P bar? So if we divide this value, that is NP bar divided by N, then N is getting cancelled and we will get P bar. So value of N, that is equal to 10 mentioned in the question. So P bar is equal to 1.5 divided by 10, 0.15. So here we will take the value 1 minus 0.15. So when we solve this, we will get 4.89. So now I will draw here one line 4.89, that is slightly below 5. So I will show here one line for the upper control limit. Now we will calculate lower control limit. So what is the formula? That is NP bar minus 3 under root of NP bar 1 minus P bar. So when we solve this by putting the value, then we will get lower control limit, that is equal to 0. So this is the value of 0, that is the starting line. So I will show here is LCL. Now how we can conclude this chart? So if we observe the two values, that is for this 9 as well as 7, that is for the sample number 5 and sample number 8, these two values are out of this control limits, that is for upper control limit. So we can say that this process is out of control. So according to this chart, this process is out of control because for the sample number 5 and sample number 8. Now there is the second question mentioned, that is we have to establish the quality standards for the future. So to establish the quality standards for the future, we have to remove the defects in the sample number 5 and sample number 8. So I will highlight here the sample 5 and sample 8 because of this process is out of control. Now we have to establish the new quality standards. So we will again calculate what are the control limits, that is upper control limit as well as lower control limit. So for this remaining, we have to plot here the points, that is for the sample number 1 it is 0, for sample number 2 it is 1, for sample number 3 it is 0, for 4 it is 3, then for 5 it is 9. So we have to remove this. Then for 6 it is 2, then for 7 it is 0, for 8 we have to remove this, then for 9 it is 0, then for 10 it is 1, for 11 it is 1, then for 12 it is 0, then 13 0, 14 3. So here is 3. So for 14 3, then 15 1. So for 15 it is 1, then 16 it is 0, 17 0, 18 2. So here is 2. So we have to plot here 2. Then 19 0 and 20 also 0. So we will extend this. So for 19 and 20 it is 0. So in this way, this is the new chart because we have removed these two samples, sample number 5 and sample number 8, which are out of this control limit. Now we will again calculate the new value. So how to calculate NP bar? So we will say this time we will take here suffix 1, NP1 bar. So how to calculate this? So formula is same, that is addition of all the defectives, and because these two defectives removed, so we will take 30 minus 9 plus 7 divided by number of k. So these two samples are removed. So what is the k? 20 minus 2, that is 18. So when we calculate this, we will get the answer 0.78. Now we will calculate P bar. So how to calculate P bar? So for this value, if we divide by 10, because n is equal to 10, that is mentioned in the question, then we will get P1 bar is equal to 0.078. So now these two values are important to calculate upper control limit and lower control limit. So what is the center line? That is NP1 bar, which is equal to 0.78. So I will mention here 0.78, that is slightly below than this one. So I will draw here one line 0.78. So this is for the center line. Then upper control limit, that is NP1 bar plus 3 under root of NP1 bar 1 minus P1 bar. So this P1 bar is known, NP1 bar is also known. So when we calculate this, then we will get the answer 3.324. That is slightly above this 3. So I will mention here. So this is the value for the upper control limit. Now we will calculate lower control limit, that is NP1 bar minus 3 under root of NP1 bar 1 minus P1 bar. So when we calculate this, then lower control limit we will get the negative value. But this control limit, if there is the negative answer, then we have to consider it as a 0. So along this 0 line we will consider this as a lower control limit. So along this line only I will show here lower control limit. Now if we observe, no any point is out of the control limit for this chart. So we can say that these are the quality standards we have to establish by removing the sample number 5 and sample number 8.
Given question, the number of mistakes made by an accounts clerk is given in the table. Establish a suitable control chart.
This is the given table where the big number from 1 to 20 is given with number of mistakes are also mentioned. Now we will solve this question by using C chart. So for C chart, on vertical line we have to plot the number of mistakes, and on horizontal line we have to plot the sample number, that is big number from 1 to 20. So we have to take here the equal distance and we will plot the numbers from 0 to 20, and on vertical line if we observe, minimum number is 0 and maximum number is 7. So we will plot here 0, 1, 2, 3 up to 7. Now we will plot the points. So for the first weak number of mistake is 1. So here is the in between 0 and 2, here is 1. So I will plot this point. So for 2 it is 0, for 3 it is 2. So here is 3 and number of mistake 2. For 4 it is 0, for 5 it is 1. For 6 it is 0, for 7 it is 1, for 8 it is 0, for 9 it is 1, for 10 it is 2. So here is the number 2, so we will plot here the point. Then for 11 it is 3. So we will take the horizontal line and here is the mistake 3. Then for 12 it is 3, for 13 it is 1. So for 13 it is 1, for 14 it is 0, 15 0, 16 it is 7. So for this 16 we will plot here one point. Then 17 it is 1. Then 18 it is 0, 19 it is 1 and 20 it is 0. So this is the plotting of the numbers. Now we will calculate the control limit. So by using the C chart, we have to first calculate average number of mistakes, that is C bar. So how to calculate the average number of mistakes, that is the total mistakes divided by the sample number. So here total mistake, that is addition of all these defectives. So we can say this also as a defects. So if we add all these numbers, then which is equal to 24. And number of samples, that is weak number 20, so divided by 20. So value of C bar is equal to 1.2. Now how to plot the upper control limit? So upper control limit is C bar plus Z sigma C. So sigma C, that is the standard deviation, is under root of C bar. So value of C bar is 1.2. So 1.2 plus 3 under root of 1.2 is equal to 4.49. And lower control limit C bar minus Z sigma C, that is C bar minus 3 under root of C bar, that is equal to 0. Now we will draw this. So centered line, that is centered line which is equal to C bar and which is equal to 1.2. So I will draw here one line. So 1.2, that is slightly greater than 1. So this is the CL. Now upper control limit is 4.49. So 4.49, that is, it is approximately 4.5. So it is in between 4 and 5. So I have to show here upper control limit. So this is UCL, and lower control limit is 0. So along this 0 line we have to plot here this LCL. Now if we observe, there is one point above this upper control limit. So we can say that this process is not under control.
Given question, the number of defects inspected in rational subgroups of size 5 and for a sample of size 10 are as follows. Set up appropriate control chart and give your comments. This question was asked Calicut MCom 1983.
Let us understand the given table. Sample number from 1 to 10 is mentioned and the number of defects for each subgroup is given. In question, number of subgroup, that is the sample size n is equal to 5 mentioned in the question. Now we will calculate the value of C, because we are going to solve this question by using C chart. So what is the value of C? That is the addition of this total defects for each sample. So for sample number 1, 2 plus 1 plus 0 plus 1 plus 2, that is equal to 6. For sample number 2, it is 3. For sample number 3, it is 7. So we have to calculate all the value of C. Now the next column we have to make to calculate value of U. So what is this U? That is the number of defects per unit. So here for the 5 subgroup, this value of C is 6. So value of U is 6 divided by 5. So if we calculate this, 6 divided by 5, which is equal to 1.2. Now in the same way, for the second sample, here 3 divided by 5. So when we calculate 3 divided by 5, then it is 0.6. Then here for the third sample, it is 7 divided by 5, because value of n is 5. So we have to divide each number with 5. So 7 divided by 5 is 1.4. So in the same way, we have to calculate the value of U. Now we will draw here one chart. So on horizontal line, we have to plot the sample number. So sample number, that is from 1 to 10. And on vertical line, we have to plot the number of defects per unit. That means that this we have calculated value 1.2, 0.6, 1.4 and so on. So how to plot these points? So for sample number 1, U is 1.2. So here on the vertical line, we will plot from 0.0, then after 5 cm 0.5, then after 5 cm 1, then 1.5, 2 and 2.5. Now here how to plot the 1.2. So if we observe, here is the value of 1, and after that, because in between 1 and 1.5 there is 5 cm distance. So after that 2 cm, here approximately this is the point 1.2. So this first point is plotted. Then next is 0.6. So if we observe, here is 0.5 and after 1 cm there is 0.6. So for the sample 2, so here is the vertical line and here is the horizontal line. This is the point, second point. Then 1.4. So 1 cm below 1.5 there is the 1.4 point we have to plot for sample number 3. So here is the 1.4. So in the same way we have to plot all the points. Now as per this calculation we have to plot all the points. Now we will calculate the control limits. So what is the center line? So center line is equal to u bar. So how to calculate u bar? So if we observe, this is the value of u for each and every sample. So if we make here the total, then it is 59 by 5. So this is the total for 10 number of samples. So u bar, that is equal to this 59 by 5 divided by total number of samples, that is 10. So we can also write 59 divided by 5 into 10. So its answer is 1.18. So this is the center line. So 1.18, we have at 1.18 we have to draw here one horizontal line and we have to plot the center line. Now how to calculate upper control limit? So upper control limit, it is u bar plus 3 under root of u bar by n. That is 1.18 plus 3 under root of 1.18 divided by 5. So if we calculate, we will get 2.64. So here after 2.5, here is 2.6. And then we have to draw here this upper control limit. Then lower control limit is u bar minus 3 under root of u bar by n. So which is equal to 0. So at this horizontal line 0, we have to show lower control limit. Now if we observe this chart, then all the points lie within these control limits, that is lower control limit and upper control limit. So this process is under statistical control.